Okay, ladies and gentlemen, my name is Szymon Łukasik. I work at Synerise as a data scientist, and I am also an associate professor at AGH University of Science and Technology and Systems Research Institute of Polish Academy of Science. I work in data science and artificial intelligence for more than I think 10 years. And what I would like to share with you is how we are applying data science in marketing automation. It will be a presentation presenting briefly both problems which are present in this domain, but also how we are tackling them at research level, and also at practical level, so how it works at Synerise. So first, I will start with some basic terms. For most of you, probably they are well known, but I would like to indicate what are the aspects which are important from the marketing automation side, and also which are the most challenging for us while we are working with large data sets. If someone would like to ask me a question, I'm sorry, I have a screen, I have a full screen turned off, so I'm of course very open for your questions. If you would like to ask some question, I will write it here. If you would like to ask me a question, please wait until the end of the presentation, and I will for sure try to respond to any question or concerns. Of course, this presentation will be shared publicly, so if someone would like to see for example, click one of the links which is in the presentation, it will be possible. So coming back to the scope of our talk. First, I will start with these basic terms, what marketing automation is about, and I will also talk about typical problems of data science and how they represent themselves in retail and marketing. So how they can be seen as a marketing and retail problems. Then I will name some of them and provide some exemplary solution. I'm saying that they are not so close because work is in progress. None of these problems can be seen as solved. Of course, we have some solutions which are very promising. But I see a lot of interesting areas already still open to explore. So we'll talk about demand analysis, segmentation, recommendation, assortment, and product matching. Price optimization. I think price optimization will be just mentioned briefly. But churn prediction and attribution, they will also be here briefly overviewed. So I will provide some exemplary algorithms and technical solutions which we are using at production level. So first, some basic terms. I already said that you know them. Maybe I will not present the terms itself, but I will say how we are seeing them here in this context of marketing automation. So when we talk about artificial intelligence here, we are not talking about general artificial intelligence, so creating thinking machines, let's say, but we are solutions which are imitating natural processes, both human and nature-based. So we are mostly doing not artificial intelligence by itself, but maybe a bit of computational intelligence. But as you will see, a lot of promising results can be done not by creating talking entities, but by implementing some solutions which are based on some natural phenomena. So we are dealing with big data, especially here in Synerise. So it has all the four aspects which you know probably from the definition. Volume, because we are dealing with really huge data sets. We have thousands of events coming every second. And this velocity is also a challenge because we try to provide the information in real time. So all the analysis have to be performed very quickly. We try to deliver value to everyone who's interested in using our services. And what is also important, this data which is available to us, it's very diverse. So we have a lot of information of various nature coming from different sources, which makes the data analysis process even more challenging. So the problem of using extracting useful information and using it for good purposes is crucial to the success of many industries nowadays. And sometimes the key relies not only in the data, because we, as you know, we can gather a lot of interesting information any second, but also at its analysis and presentation. Here we have an example. Here it's an example of special demand analysis. It's a map of BART users in Bay Area. And if you would simply create a map showing the users of BART transportation system, then it would look with simple dots. The size of the dot, it's not the number of users in this area, it's the number of users normalized by the distance to the nearest station. So essentially big bubbles here present areas which need more substantial involvement of public transportation. So as you can see, it's not only about the data, it's also how we present them to the user and how we make the user aware of some facts, and also how he can use this information for his purposes. To solve these problems, we are doing machine learning, so algorithms which are based on computer ability to learn without being explicitly programmed. Some of those algorithms are being shown here, of course not all of them, and we are trying to develop algorithms which are robust and which are able to tackle the problems which we have already mentioned, those 4 V's. This field is very challenging and also quickly developing. We will not talk about other problems like problems of infrastructure, problems of personnel, and other issues, and they are present, of course. But this interest in this area is growing very fast, which can be seen on this graph, and it's not a surprise for everyone that the number of industry entities working in this industry is really huge. So we are just one piece of the map, trying to do as much as possible. So what is marketing automation, and how we understand marketing automation? It's not a surprise that it's called marketing automation, because as you may know, automation is a field of electrical engineering, mostly working with systems with some inputs and outputs and some state. And in automation, we try to develop algorithms which basing on the input are giving output useful to the user. So automation is mostly about machines, and marketing automation is about data and some decisions which are made in marketing contexts. So as a data, we usually have some data from e-commerce, some personal demographic data, transactions, and also engagement data. So it's not only about people buying things, but also people about clicking links, looking at things, rejecting, because sometimes rejection of a given suggestion is even more useful than people's involvement. So and also mobile and device data and things like location. We can also have sensors installed in POS. So we have a lot of different data which is available, and also it's a data not only about users but also about items which are being considered by each individual user. So it's essentially a lot of data coming from business. And marketing automation is about processing this data, doing, for example, dynamic segmentation, omnichannel attribution, recommendation, churn prediction, and other types of predictions. And also a lot of different things, which in turn comes out and determines actions made on output channels like email, mobile messaging, SMS, social media, POS, personalization. So a lot of output comes of the marketing automation systems. And it's not only about deciding which channel to choose, but also what should be the content, and also when to direct this message. So there's a lot of ifs and a lot of things coming in the system to decide optimal decision based on the available. So essentially, what we're trying to do is help businesses, but also help customers, because it's not only like maximizing the business outcome, but also giving useful information to the user, which is also important from his perspective. So some of the problems we are dealing with right now, I will present them briefly. So what are the practical machine learning problems we are dealing with? And how they manifest themselves in retail and marketing. So cluster analysis is the first problem, which is called clustering, in other words. So segmentation or grouping. So a division of customers or activities into a group of similar characteristics. Of course, it can be division of customers. It can be a division of activities. And it can be also a division of products. It can be a division of baskets. So the input data can be of diverse nature. The problem is to create some groups of objects which have similar characteristics. Then when we have these groups, we can make a decision individually sometimes on the action which should be done on each group. Ideally, the number of clusters shouldn't be determined in advance. Then we have a task of classification, which is assigning a user to one of the predefined classes. So we have classes which are already created, and we are trying to assign a user to one of them. One of the things which can be think of as a class, for example, is a class of customers. which is based on the engagement. For example, simple binary classifications is a classification of customers which are possibly going to churn. So they are possibly planning to abandon our services, or they will abandon our services in the future. So, and the other thing is prediction. So predicting events that they are due to happen in the future. So for example, transaction, if someone is going to buy this product, or for example, some other action like clicking on the link, or even some more general type of prediction. So for example, what will be the amount of money spent by all the users in the given store on the given day? So the kind of prediction can be like very coarse or very grained. So the type of prediction is different regarding on the problem which we are looking currently at. So next type of problem is a problem of recommendation, which is very well known in retail. It's one of the problems which everyone who works in retail is aware of. So indication of an action which is optimal according to the available data. Intentionally, I'm not talking about suggesting a user product, which is because it's a very, very narrow understanding of recommendation. Recommendation can be also a recommendation for a system operator to do some action. For example, distribute a campaign in the given moment. So recommendation is not only a recommendation in retail, in customer perspective, but also a recommendation as a decision support system to operator which is working on given e-commerce platform. Network analysis, so indication of important nodes and relations. So essentially a lot of entities like customers or products are linked, inherently linked by some kind of relation. People are linked by personal relations, but they are also linked by similar baskets in given store. So this kind of analysis have to take into account those links. So essentially, a lot of things we are doing is a network analysis, so working with graphs. First, let me give you an example. For example, this example will be a customer segmentation. So it's an example from the literature. So we have a customers groups which are supposed to be found for a mobile phone operator. It's not very up to date, like because you can see the number of users is very low. So it's only a piece of the business for this operator, and we are considering a lot of different features for each user, like average revenue per user, minutes of usage, ratio of calls in different aspects like internal, external, and IP calls, and ratio of roaming calls, roaming and idle time calls, and number of different numbers users have dialed, which is called call diameter. And if you consider these attributes as features to machine learning algorithms, you are essentially doing clustering for 8 attributes, which is not a very difficult problem. And the outcome of this analysis can be very interesting to a mobile phone operator, because it essentially uncovers 3 clusters from this data, and operator can do optimization of his strategy, taking into account those clusters. We've been doing similar studies at our research group at Polish Academy of Science for one of the Polish operator, and it really works like charm. So clustering can uncover really interesting results for mobile phone operator, because essentially you can find some patterns in the data which are clearly distinguishable. For example, customers group number 2, they are not using the phone so much in terms of calling, but they are sending a lot of SMSs, as you can see, comparing to the global mean. And group number 3, they are really saving money because they are doing a lot of calls in the night. This operator has a lower fee for during calls in the night. So as you can see, segmentation is a very useful tool in marketing automation, which can uncover really interesting things. We are doing this segmentation not only on customers, but also on other data. I will talk about it briefly in a moment. Prediction. So prediction is a task which is very difficult, but also very rewarding when you solve it properly. It's very interesting to find some relations, not only about who is likely to convert, but also where it's going to happen. So you can not only analyze what is going to happen in the next 168 hours, but also you can try to analyze how it's going to distribute among different areas. You can also create, which is not visible here on the slide, some summaries, because what we are trying to do is not only provide user with data, like with results, but also to summarize them in an explainable way. So this is also a very important aspect in automation, is not only deliver the result, but also present them in a way which is useful to the user. This is also very important in the context of prediction. So what is going to happen? Who is going to resign from our services? And it's not only important from the aspects of if it's going to happen, but also why it's going to happen. So what are the features in the model which are interesting? In data science, we are doing a lot of black box models, especially recently. We are using very heavily deep learning. So one of the things which is challenging, and we try to address it in our studies as well, what is the impact of individual features on the output of the model, and it's not only about general impact, but also an impact on individual decision. So why this customer was classified as one which is going to churn? Why this item should be removed from the store? So this information is very important, and in fact, what we are doing is reverse engineering of machine learning algorithms. So we are doing additional machine learning to uncover which features are important. Okay. And when you think about decisions, it's also important to not only what content to choose or to whom it should be addressed, but also when to send it. I already mentioned that. And we are also doing time optimization. So we try to provide an information when the action should be performed. What is also important in automation is to identify which decision has led a user to some action, which information has led the user to some action. So, for example, if he has made a purchase because of an email which has been sent to him a week ago, or he just made this decision on the impulse because he saw a banner on some well-known Polish portal. So one of the things which we are also doing is attribution. So attributing some elements on this path of the user to convert, attributing this element a higher or lower impact on this final decision. So essentially, we are also doing attribution, and not only like simple first or last touch attribution, which is very well known, but also attribution made on based on deep learning algorithms. Of course, recommendation. You probably know recommendation algorithms very well. You have seen probably a lot of times suggestion while you're browsing, which is based on your previous activities. But what is more sophisticated, and I would like to talk about it because it's more probably more interesting, is visual recommendation. So basing on the visual information, essentially simple approach can be based on doing some kind of image representation, like using some neural network to provide embedding of the data. So essentially the image is then represented by a sequence of numbers, and on this sequence of numbers you can do a lot of different stuff. So you can do clustering, so you obtain a group of similar images. You can do some other embeddings like dimension reduction. So you can get a two-dimensional representation to show it to your user. And you can also do some outlier detection, so detect atypical elements. It is very rewarding to see how it works, because we have developed it for many customers of Synerise, and it's really working astonishingly sometimes. We have this is an example of two-dimensional embeddings of shoes. As you can see, this cluster is of high heel shoes is very clearly visible. But it's only one of the side of this problem, because you're usually not taking into account only image of the product, but using our tools, you can also do a visual recommendation basing on the image of a person dressing some things. I think around half a year ago, our company was flooded by our internal communication was flooded by images of our colleagues dressed in some stuff, and then with some suggestions from the stores, giving this precise pair of shoes or shirt which our colleague is wearing. So it's really working surprisingly well, I would say. And we are not only taking into account the image in this kind of tasks, because you also have some textual information available in this kind of problems. So you also have user activities data. So, for example, if someone is clicking on the similar products, so it's essentially a problem of information fusion. And we have developed an algorithm which is aimed to solve that problem. You can see a link on the bottom of this slide. So this is an algorithm of multimodal embeddings, which is really working very well, and we have a paper published in this area. You can embed not only images, you can embed users, you can embed baskets, and then if you will embed baskets, then you essentially find similar products, similar baskets, which can be later used in the task of recommendation. I will talk about it in a moment. How you are doing it? You essentially try to represent baskets by a sequence of IDs, and then you do entity embedding. We have our own in-house algorithm, which is called Cleora. Recently, it was open sourced, which does entity embedding. So it doesn't embed only products and baskets. You can do almost every type of data which has some kind of relations between them. And essentially, when you do entity embedding, you have each product is then represented by a vector of numbers of given length. So if you have these vectors, then you can compare them. For example, find similarities, find products which are very close to each other, which then serves as an input for an algorithm which can be used for recommendation or assortment optimization. I will talk about it in a moment. Recommendation is not only about providing some information to user, but also tuning it. So it's not only about providing similar products or popular product or products which are which have similar image or which were both by similar users, but it's also about providing different products. So we don't want a user which has just bought a smartphone to suggest only 5 charging cables of the same type. We want to provide a variety among the information which is available. So so I would say that it's a challenging problem, and we besides optimizing it, we also provide the user an option to tune it for his own purposes. Of course, recommendation, as I said, is a very challenging problem, and just to relax the atmosphere a bit, you can see some examples where it just simply didn't work. For example, suggesting some other accessories for a user who is looking at baseball bats, which are clearly not designed for baseball, or suggesting a user an article in the language he doesn't know while he's being in Katowice, or providing a user who just looking at her groomer suggestion to look at Chronicles of Narnia box set. So as you can see, a lot of things can go wrong, and one of the things which is important for us is also filtering those bad results to not make this kind of embarrassment. Of course, it's not result which we have provided. What we are recently working very heavily on is assortment optimization. So providing optimal set of products on the shelf. And it's not about putting products on the shelf like you can see here in the place, but selecting the products which should be on the shelf in the given store on the given day, taking into account constraints. So how many products can you have in this shop, or how many changes during the week can you do? So it's very challenging. It's not only challenging because of the fact that that there's a lot of information, a lot of prediction tasks to be done as well, but also you want to take into account other businesses which are your competitors. And the problem is that sometimes when you try to analyze this data, you don't have a compatibility between products. You have a product description of one customer and the product description of one seller, and the product description of the other seller. And sometimes, even though they concern the same product, they are not compatible. So what we are doing as well is product matching, which is essentially a very complex task if you consider it more closely. Someone who has looked for some specific model of laptop maybe will understand how this task can be daunting. Essentially, it's a problem of entity matching. So matching a product with different type of data. We have also developed our in-house approach to that, which is called efficient manifold density estimator. And we have won Rakuten challenge by using this algorithm. So essentially, we are doing we represent each type of data by multi-model descriptors, and then we do a manifold representation and partitioning. And this data can be then analyzed by creating sketches, and then this information can be either an output for a classifier, or it can be essentially an information about similarities between objects. So if you are interested in details of this approach, you can also look at our paper. I'm briefly coming to an end of my presentation. I want to say that it's very important. The data quality is very important, as you were seeing on this slide just a moment ago. This data quality can be dependent not on our laziness, but also on the inherent nature of humans, that they want to invent also in this area of simple descriptions. And it makes the problem very challenging also from the performance point of view. So we also developed our own in-house memory storage, which makes efficient real-time queries possible, which is scalable and offers compression as well. So it's also another solution which makes all these wonders which you have seen possible. So coming up to the summary, I would say that as you can see, there's a lot of things possible in this area. A lot of challenges still open, and I encourage you to experiment. We are living in the world where a lot of things are on the market, which are available as an open source algorithm, or which are very simple to implement. And I encourage you also to contact if you need any further guidance in this area. And thank you very much for your attention. I'm open to your questions now or later using email. So let me stop sharing. Yeah. So do you have any questions? As I told you, all of those, the presentation will be available, and you can check out. I encourage you especially to try Cliora, which is really amazing in creating very useful embeddings. It's written in Rust. It's blazingly fast, even though for large data sets. So it's really is really something which is a game changer for in our perspective, is a game changer for retail industry, and not only to retail industry, because it can be used in other tasks as well. I cannot see anyone raising a hand. You have to, technically you have to apply for asking a question. Sorry, that's how it works. Okay, how much user data events is required to efficiently recommend users some products in online store? It's a very good question. It's not like we have some rule of thumb in this area. It depends on the complexity of the problem. So, how many users do you have? How many products do you have? Because it depends on this complexity of the problem. And how many information do you have regarding the product? So whether do you have simple descriptors, like for each product you only have name of the product, brand, and price, or do you have some other information available, like a picture or some features like characteristics, for example, in terms of fashion things like color or material. So it depends. It's not. I cannot understand. I cannot respond to your question directly, like to say, for example, okay, if you have a store, then 1 million events, it's enough. It's impossible, because it also it's also important what kind of events do you have. Some customers are providing only transaction data, so if someone has just bought things, especially when they start to work with in e-commerce, but then they discover that some other information, like visits, like clicks, it makes this process more effective. So what I would say that is it's very important to provide as much information as possible, and it's not very complex, because the integration, for example, with us, it's very simple. It can be done within days or even hours sometimes. So yeah, I guess. Thank you. Thank you. It was a real pleasure to present here at this event. It has attracted a lot of interesting speakers and also interested viewers. I hope you will enjoy it, and I encourage you to listen and to broaden your horizons, because right now in this difficult time, it's our only window for the outside world to sometimes to listen to people talking about interesting things. So I'm going to listen as well. Thank you. Have a good day, and keep in good health. Yeah. Bye.